jumped out of a spaceship above Earth, you'd hit the ground in minutes. But if you jumped out above Saturn, you wouldn't hit anything. There is no ground, you would just fall, forever, or at least until the atmosphere crushed you into a diamond. Let's simulate the ultimate one-way trip into the solar system's biggest gas giant. It is the jewel of our solar system, a majestic ringed colossus floating nearly 1 billion miles from the sun. It has captivated astronomers for millennia. It is beautiful. It is serene. Saturn is not like Earth. It's not like Mars. You cannot land on Saturn. There is no rocky surface to plant a flag on. If you tried to stand on Saturn, you wouldn't just fall, you would fall forever, until the universe itself crushed you into a diamond. Today, we are going to take that journey. We are going to design the ultimate probe, or perhaps send a very unlucky volunteer on a one-way suicide mission into the heart of the second largest planet in our solar system. We're going to find out what it looks like, what it feels like, and what it sounds like to drown in a planet made entirely of gas. Before we dive in, we need to understand the beast. Saturn is massive. You could fit roughly 760 Earths inside its volume. Despite this size, it's incredibly light. It's the least dense planet we know of. Its average density is actually lower than water. The old joke is that if you had a bathtub big enough, Saturn would float, which is true, although it would leave a terrible ring around the tub. It's composed mostly of hydrogen, about 96%, and helium, about 3%, with trace amounts of methane, ammonia, and water ice providing those beautiful subtle colors. It's a gas giant in the truest sense. Our mission profile is simple: arrive, slow down, and sink. We need a probe built like a tank, shielded against radiation, extreme cold, and eventually, unimaginable heat and pressure. We'll equip it with humanity's best sensors, cameras, and microphones to transmit data back until the bitter end. You can't visit Saturn without acknowledging the rings. As our probe approaches, the view is paralyzing. From Earth, they look solid like a vinyl record. Up close, they are a chaotic, shimmering blizzard. The rings are not a solid disk. They are made of countless billions of particles of water ice, ranging from grains of dust to chunks the size of a bus, all orbiting Saturn independently. They are incredibly wide, spanning roughly 175,000 miles, but shocking thin. In many places, the rings are only about 30 feet thick. Relative to their width, they are thousands of times thinner than this sheet of paper. If you were standing on Saturn's equator, looking up, the rings would look like an impossibly thin silver razor blade, slicing the sky in half. We have to be careful here. Crossing the ring plane is dangerous. A collision with a marble-sized chunk of ice at orbital velocities would annihilate our probe instantly. We adjust our trajectory, soaring high above the main rings, looking down at their intricate structure, the gaps carved by tiny, shepherd moons like Pan and Daphnis. But we aren't here for the rings, we're here for the planet. The rings are behind us now. Ahead lies the beige, banded atmosphere of a giant. The moment of commitment has arrived. We begin orbital insertion. To fall into Saturn, you first have to stop missing it. We are currently orbiting at tens of thousands of miles an hour. We fire our braking rockets, bleeding off velocity. Gravity takes hold. We begin to spiral inward. Where does space end and Saturn begin? On Earth, we have a solid ground to measure from. On a gas giant, scientists use pressure levels. The surface is arbitrarily defined as the point where atmospheric pressure equals 1 bar, roughly the same air pressure at sea level on Earth. We are currently in the exosphere, hundreds of kilometers above that 1 bar surface. It is freezing here, nearly minus 300 degrees Fahrenheit. The atmosphere is incredibly thin hydrogen gas. We hit the upper haze layers, the ride gets bumpy. Even though the gas is thin, our extreme speed creates friction. The heat shield begins to glow orange. Plasma trails behind us. If you were looking out a window right now, the sky above would transition from black space to a deep alien violet, and then into a thick, yellowish ammonia fog. Welcome to the troposphere. This is where Saturn's weather lives, and what weather it is. We are punching through clouds of ammonia ice crystals. We need to talk about the wind. On Earth, a Category 5 hurricane has winds of maybe 160 mph. Here in Saturn's upper atmosphere, the winds whip around the equator at 1,100 miles per hour, 1,800 km/h. That is faster than the speed of sound on Earth. Our probe is being tossed like a leaf in a tornado. We are moving horizontally almost as fast as we are falling vertically. Depending on where we drop, we might see the strangest weather phenomenon in the solar system. At Saturn's North Pole, there is a perfectly hexagonal jet stream, a six-sided storm system, twice the size of Earth, that has been raging for decades. Why is it a hexagon? Fluid dynamics simulations suggest it's a standing wave pattern in the high-speed winds, but seeing it up close, it feels unnatural. As we sink deeper, the ammonia clouds thicken. The light from the sun fades into a twilight gloom, and then the fireworks begin. Saturn experiences great white spots, massive storms that erupt periodically and encircle the entire planet. We are caught in one. The lightning here is intense. The radio signals from these lightning discharges are thousands of times stronger than terrestrial storms. Our probe's microphones are picking up a continuous, booming roar. We have passed the 1 bar level. We are now truly inside Saturn. The temperature is rising. The friction of our descent and the increasing atmospheric pressure are heating things up. Below the ammonia clouds, we hit a layer of ammonium hydrosulfide clouds. It smells terrible here, like rotten eggs. Deeper still, the pressure is now 10 times that of Earth. We are about 100 miles below the surface. The temperature is almost bearable now, creeping up towards freezing. Below us lies a massive layer of water ice clouds. Yes, Saturn has water. Massive thunderstorms of water vapor hide down here in the dark. At this point, about 300 miles down, the pressure is immense. It's like being a kilometer under the ocean on Earth. The sunlight is gone. The only light comes from the terrifying lightning flashes illuminating towering thunderheads around us. If you were a human in a standard spacesuit here, you would already be dead. The suit would have crumpled, and the nitrogen in your blood would be doing terrible things. But our robotic probe is built sturdy. It continues the fall. We are now entering a realm where physics, as we know it, starts to get weird. We are thousands of miles deep. The atmosphere above us is heavier than any mountain. The hydrogen gas around us is being squeezed so tightly that it doesn't know if it's a gas or a liquid anymore. This is called supercritical fluid. Imagine a fog so thick it behaves like syrup. There is no splashdown. We don't hit an ocean surface. The gas just gets gradually thicker and hotter until we are swimming through it rather than falling. The heat is now incredible, thousands of degrees. Our probe's outer layers are melting away. Sensors are failing one by one. The camera lens is fused shut. We are blind, but we still have telemetry. We are approaching the most mind-bending part of Saturn, the deep interior. At roughly 15,000 miles down, about halfway to the center, the pressure is 2 million times Earth's atmospheric pressure. The temperature is hotter than the surface of the sun. Here, hydrogen, the simplest, lightest gas in the universe, is crushed so violently that its electrons are squeezed off its atoms. It becomes liquid metallic hydrogen. This isn't science fiction. This is the real stuff inside Jupiter and Saturn, a vast, churning ocean of liquid metal hydrogen, tens of thousands of miles deep. It conducts electricity perfectly. This churning metal ocean, rotating rapidly as Saturn spins, is the dynamo that generates Saturn's massive magnetic field, a field 578 times more powerful than Earth's. Our probe is doomed. It has survived longer than expected, but it has entered the metallic ocean. The heat vaporizes its metal skin. The pressure crumbles its strongest internal supports like aluminum foil. The probe doesn't hit bottom. It becomes part of the planet. Its atoms are scattered into the metallic hydrogen sea, joining the eternal flow of the giant. What lies beneath that metallic ocean, we don't know for sure. Current models suggest a rocky, icy core down there. A solid center, perhaps 10 to 20 times the mass of Earth, crushed into a dense ball, subjected to temperatures of roughly 11,000 degrees Celsius, 20,000 Fahrenheit. But no probe will ever see it. The journey ends in the metal sea. On September 15, 2017, humanity actually did this. Well, almost. The NASA Cassini spacecraft, after touring the Saturn system for 13 years, was running out of fuel. To prevent it from accidentally crashing into and contaminating moons that might harbor life, like Enceladus or Titan, NASA ordered it to dive into Saturn. It didn't get deep, it burned up high in the atmosphere, transmitting data until the very last second, tasting the atmosphere of the giant it had studied for so long. A warrior's death for a magnificent machine. Falling into Saturn is a terrifying concept. It is a journey from serene beauty into unimaginable violence, heat, and pressure. It's a reminder that the universe is not built to accommodate humans. Most of it is hostile, extreme, and deadly. But it also reminds us of why we explore. To look into that abyss, to build machines that can survive it for even a few minutes, just to learn what's down there. Saturn is a beautiful, deadly jewel, and some part of us will always want to touch it.